Hi everyone, this is a update of the resonant coil, and before we start we'll do some calculations here. This battery here is what's feeding the logic of my circuit, and just to demonstrate we'll check the voltage of that battery. So there's my terminal to the positive, and I'll just connect the negative terminal here. And we've got exactly 12.3 volts in that battery there. Okay, we're back, and what I've done is I switched the meter to milliamps now, and this is the same bulb that I use in the circuit here. I just have it fitted inside this plastic piece here. That's a dash light bulb for automotive purposes. All I want to do is just demonstrate how much, what is the amp draw on this bulb. So the bulb is lit at 12.3 volts, and it's drawing 91.8 milliamps. So pretty close to 92 milliamps. There you go, 92 milliamps. Alright, so here are my findings. We have 9 volts now, I readjusted, entering the circuit, and there's the circuit. I've taken away the capacitor from the circuit and brought it on top here because I've discovered there's no radiant energy that happens on this side of the leg, and so keeping the radiant energy inside the coil right here. And the other lead is going directly to the coil, okay, and there's no radiant energy on that lead because that's the starting point of the coil. So the idea is not to bring the radiant energy here at all, is to keep it all contained in the coil. And yesterday when I was noticing the temperature rise in my capacitor, I thought, geez, there's a lot of energy in there. Even with the light fluorescent bulbs, I wasn't it was still heating, so I thought there's still a lot of energy in there, and I thought, let's see, since the fluorescent bulb is lighting, if we can get the light a regular light bulb. And I just had an idea to just quickly wrap around one alligator clip and attach a light bulb, and it lit. And then I added another one in series to add more turns, and it was getting brighter. And here's what I found now. This bulb is a 12 volt automotive dash bulb, and that is lit to full brightness, and actually even higher than 12 volt at this time. And what I found is actually, I don't have the alligator clips on it anymore. This is a solid core 14 gauge electrical home wiring that's just coiled 3 turns exactly. Any more turns and the intensity of the light output goes down, and less it goes down. 3 turns at 9.6 volts. My average I've been able to calculate is it's drawing between 10 to 12 milliamps maximum. 10 milliamps minimum to 12 milliamps maximum. And that's at 120 volts. Anybody that knows a bit of Tesla's work, I didn't steal this off Tesla, I just had the idea to try that. And after I saw it, I realized this is exactly what Tesla was doing in his ozone patent. You'll see a long coil, and then a secondary that's only, I don't know how many turns, but a very small amount of turns coming around it. So that's the secret of extracting the energy out when the coil is in resonance. Now the other really amazing thing is I've got my probe on it here to show you the voltage, and there you go. So that's the frequency it's resonating at, 312 kHz, and the peak to peak is there, and it's obviously outputting more than 12 volts. All right, the transistors are not hot at all. There's hardly anything noticeable there. And look at this. This is what the form looks like. And if you know of the helix, which is the DNA in our body, what the helix would look like, you would recognize this as a DNA helix as well. So quite interesting that it's producing this most amazing helix. Now it does funny things with the video, and I'll post a solid shot of it in the video as well. The other thing I was saying is, before I came up with the picking up of the energy, like I was saying, the capacitor here would get really hot, and when yesterday the energy was so much that when I put my finger at the back of the capacitor, the plasma came out of the capacitor and burnt a hole right in this finger. I swear to God, yesterday there was a hole in my finger right here. And today that hole is completely gone. It's not visible. I can't see it anyways. Maybe right here there might be like a little white spot, but I tell you, it was a burnt hole, and it smelt like burnt skin, very seriously. The other interesting thing is that burnt hole in the skin and everything, while it was happening, I was holding my finger and I wasn't realizing it until I smelt the burnt skin, that it was my finger that was actually being burnt. And so it shows you that there was actually, I wasn't getting an electrical shock. And also, there was no pain whatsoever related to this burning of the plasma. So I believe there's a discovery here for use for surgical application with this kind of electricity plasma, as it doesn't hurt, there's no pain, there's no electrical shock, and there's an amazing ability of it to heal very fast too. So this is a discovery for the world.